All right, so I think I'm recording here. Let's take a look at these two absolute value inequalities. In each case, the absolute value is isolated, it's by itself. Um, and we have two different situations illustrated here. In problem 3, the arrow is pointing away from the absolute value. So I know that when my solution set, my shaded region on the real number line is going to be out away from the center, out in the tails. And then in problem number 4, the inequality, the arrow is pointing towards the absolute value symbol. So I know that the center portion of the real number line is going to be shaded in my solution set. So let's take a look at each one of these. We have that this x divided by 5 is going to be less than -1, or this x divided by 5 is going to be greater than +1. And that's what you're always going to do in this situation. You're going to drop the absolute value symbol, change the direction of the arrow, and change the sign of the number. And then on the second inequality, it's a lot less things to do. You just simply drop the absolute value symbols. So here on the left, I'm going to multiply both sides by +5. And that means that x is strictly less than -5. And over here on the right, I'm also going to multiply both sides of this inequality by +5, and that means that x is greater than 5, strictly greater than 5. So if I make a sketch on the number line, my critical points, my boundary points here are -5 and +5, and the decision now is whether to shade these and make these endpoints, to include them in the solution set or to exclude them. The arrow is not underlined, it's a strict inequality, so I need to leave these hollow. I cannot shade these in. And value these numbers x strictly less than -5 means that you're to the left of -5, so we shade in this portion of the number line. Or you're over here where x is strictly greater than 5, which means that we shade to the right of 5. Those numbers are all larger than 5. To write this in interval notation, the left arrow is shaded. We always start with the smaller value, comma, the larger value. So it's -infinity, comma, -5. But this time I do not include that -5, and I have a parenthesis around that. Since now there's a break in my graph, I need a union symbol. That's the word or. You're in this interval, or you're in this other interval that is from 5 to +infinity. So that's how we write our solution set in interval notation. All right. Let's take a look here at number 4. Now at number 4, well, there's something I noticed right away about number 4. Remember what absolute values are. Absolute values represent a distance from the origin. And absolute values are always 0 or positive. And this inequality is saying that this absolute value is less than or equal to a negative number. And there's no way that that's ever going to be true. Absolute values are always 0 or positive. They're not less than -2. So I can immediately see that this is good. This is a situation that's no solution. It doesn't even make sense when you think about the definition of absolute value to say that a number that's 0 or positive is less than a negative number. All right, so I hope that helps, and I will talk to you later. Bye.